Hello, I'm Alex Gross, and this video is to introduce a mutation testing tool called the universal mutator. The universal mutator is written in Python, and to install it, you just type pip install universal mutator. You can also download the source from GitHub, but actually we strongly recommend you install from pip at present. So what does the universal mutator do? Well, I don't have much time, but I will tell you that it is a regular expression-based mutation generation tool that generates mutants for mutation testing and actually will run tests for you, as you'll see in a moment. And the big innovation here is that it's purely based on regular expressions. It doesn't parse the language that it's mutating, which means the important thing here about that is that it's easy to write tools for new languages that did not previously have a mutation testing tool. So here is the very quickly written rules for mutating Swift programs. Now, these don't look like enough rules to actually mutate Swift programs, but they are joined by the fact that Swift is a C-like language, and there are rules, the universal rules for mutating all languages. And these actually encapsulate a lot of the operators, for instance, that Jamie Andrews used in his well-known tool for C and in some major papers on mutation testing. So let's see how the tool works in practice. So large small.swift is a small Swift program. It's just one function and then a test. We've annotated the test code with do not mutate, so it won't be mutated. And this is Swift, so we can just merge like a function definition and then some actual test, and we can just run that as a script by doing Swift large small.swift, and of course the test passed. It's not a very interesting test. You can guess that this is not going to be the best testing for killing mutations. We take one sorted array and assert that our function indeed finds the largest and smallest elements. So how will we mutate that? Well, we type mutate large small.swift. Our system figures out that it's Swift. It applies the appropriate rules. It tells us about the mutants it's generating. Some of them are invalid. They don't even compile. Some of them are valid. They're real mutants. And some of them are redundant, which means that they are valid. They compile, but the actual object code is equivalent to an already generated mutant or to the original program, so they're not of interest. We don't need to run them. It uses trivial compiler equivalents to do some simple pruning of mutants you don't care about. So once we've done that, we can run it. The mutants. So we tell what program we're mutating, and then we just say, how do I run the tests? Well, in this case, it's very easy. We just run Swift on large small.swift. What this is going to do is drop in each of the mutants and tell if the test kills it. So our poor test suite, unsurprisingly, gets a mutation score of only 0.65. Only 65% of the mutants are killed. Now, even this very weak test suite actually kills quite a few mutants. So the universal mutator also includes some tools for handling coverage and makes it easy to write your own rule files and drop them in to control things like which code is mutated and which not. For instance, if you don't want to mutate warning statements, that's easy to do. The paper contains many more details about the tool. And again, if you want to install it, just do pip install universal mutator. Thank you.